Okay, welcome to 3G. At this point, you should have filled out all these tables and tried to plot all these graphs. And so when you're watching this video, you're just checking to see if you came up with the right stuff here. And you should have done it in pencil, so that way, if you make mistakes, you can fix them. Okay, so if you haven't done this yet, go back, fill in the tables, you can do this, and plot the points and see if you can come up with the right graphs, because that's what we're going to be doing eventually, is that you're going to plot and come up with these graphs on your own. But it's going to be a little bit easier once you know what they look like. So we're going to go through your notes now once they're filled out and make sure that you've done these all correctly so you know what these look like. And I'm going to zoom in on each one. All right, so y equals x. Well, what you should have ended up with is a graph that looks like a straight line. Straight line. Okay, and I'm just drawing mine freehand, but it's every point like this going on forever. So -3, well, y equals x, so whatever x is, the y is. So -3, -2, -1, 0, 1, 2, 3. And then we can see that since -3 is going to go with -3, you get a dot there. -1 goes with -1, you get a dot there. So you have a straight line. It's a linear equation line going through all the squares on the diagonal. So that is our linear graph. All right, what about the inverse? Well, something interesting happens here. When I put -2 under here, I get -1/2. When I put a -1 in for x, I get -1. Now what happens when I put in a -0.5? What does that mean? Well, this is saying a positive divided by a negative. Well, that's still negative. We've got that. And then 0.5. Well, if I take 1 and divide it, because that's all this is, divide it by 0.5, I get 2. Because a half goes into a whole twice. And then we put 1 over 0. Well, if you type this into a calculator, you should have gotten an error because this is just undefined. We can't actually divide anything by a 0. So we're just going to write in undefined here. So now all of these, we should see a pattern going on. But if I divide by 0.5, instead of being negative, since this is positive, this is going to be positive. Divide by 1 is 1, and 1 divided by 2 is 1/2. And then it would have been pretty hard to draw this graph without really knowing what's going on here. But let's go ahead and plot these points, and I'll show you what it looks like. So if we go to -2, and I know it's a little blurry, I'm doing my best to read here. 1/2 is right about there. Then we have -1, -1, and then we have -2, whoops, sorry, 0.5, so 0.5 goes all the way down to 2. Now you probably don't know how to connect this, and you probably got it wrong unless you're familiar with what this looks like. But let's figure that out in just a second. Let's plot these positive ones. So 0.5 goes with 2, would be right there. 1 goes with 1. And 2 goes with 1/2. All right, so as I put in bigger, or actually smaller and smaller negative numbers here, so if I were to put 1 over -3 and 1 over -4 and 1 over, let's just jump to -10 and 1 over -100, you can see how we're getting closer and closer and closer to the x-axis, right? Because we're plotting. As we get over here to -10, we're only at -1/10 right there. And as you get over here to -100 for your x, now you're at -1/100. So that's a really small space between the x-axis and your point. So what's happening here is this line is getting closer and closer and closer and closer and closer and closer, but it's never touching, just like that. And then on this end, well, the same thing is happening. As this number gets smaller and smaller and smaller and closer to 0, as this number gets smaller, this number gets smaller this way. And so it's also going to come very close. It's going to pass through that point we did without even touching the x or y axis. And whoops, that's not drawn very well. But the same thing's going to happen up here. It's going to curve around like that. And now as I put in bigger numbers, let's put in some bigger numbers for x. Let's say we did 1. When x is 10, y is 1/10. Well, when x is 100, y is 1 over 100. So we're getting an even smaller number. When x is 1,000, y is 1 over 1,000. So you can see how this number, this y, is getting closer and closer to 0 as the x's get bigger. So it's going to get closer and closer without ever touching the x-axis. And then same deal here, closer and closer without ever touching the y-axis. So that is what the inverse function looks like. You're probably just going to have to memorize this to remember what it looks like, because it's going to be hard just to plot the points. Whereas on this one, you plot some points, you connect them, it's pretty straightforward. All right, so this one's the hardest one we're going to look at. Let's look at some other ones here. All right, y equals x squared. So if I plug in -3 here, I'm going y equals -3 squared. And we've talked about this a few times, but if you do not put parentheses around here in your calculator, it's going to give you a negative. You have to be smart enough to know that a negative times a negative equals a positive. So when I square this -3, I'm going to end up with a +9. And the same thing happens here. When I take -2 and plug it in and square it, I end up with a +4. 1 squared is +1, 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. Now I can plot all these points here. I have a point at 0, 0. I have a point at 1, 1. I have a point at 2, 4. It's really small for me to see here. Okay, there we go. So what does this look like? Well, here are our points, and then you have to know that this x squared, every time you see an x squared in there, it's going to look like a u. So when you connect these, it's not pointy at the bottom, it's rounded, and it goes up forever. I kind of missed my points there, but you should have a u drawn on your paper for this one, just like that. Okay, a cubic function. So what happens here? Now we're saying that we're going to take -3 and we're going to multiply it by itself 3 times. So is that going to give us a positive or a negative? Well, let's see what happens. -3 times -3 times -3. Well, -3 times -3 gives us a +9. And then we still have to multiply it by this -3. That gives us a -27. So you should have gotten a -27 here. And I told you in the directions, if you can't plot that point, don't worry about it. Let's see what happens for when we plug in -2. So we have -2 times -2 is 4. And then 4 times -2 is going to give us -8. And then -1 times -1 is a +1. Times another -1 is going to give us -1. 0, no matter how many times you multiply it by itself, is going to be 0. 1 times itself, so 1 times 1 times 1 is still 1. And then 2 times 2 times 2 is 8. And then 3 times 3 times 3 is 27. So what should this look like? All right, so if you have these points wrong, correct them now and see if you can plot it and come up with the right picture here. So here's what your point should look like. And then again, it's not pointy here, it's actually curved like this. Curves up and it curves. Try your best to hit the points, not like I am doing here. And it curves down. All right, that's our cubic function. Absolute value. Well, absolute value, a little reminder if you don't remember what absolute value is all absolute value is saying distance from 0. So if we have 0 here and we're saying -3, so y equals the absolute value of -3, it's saying, okay, well here, -3 is 1, 2, 3 spots away from 0. 1, 2, 3 spots away from 0. -2 then is 1, 2 spots away from 0. -1 is 1 spot away from 0. And then 0, well 0 is right at 0. And then we have 1, well how far away is 1 from 0? Well here's 1, well it's 1 spot away from 0. Here's 2, 2 spots away from 0. And here is 3, and it is 3 spots away from 0. Another way to think about it is that absolute value, when you have negatives, they're going to become positives. When you have positives, they stay positives. Don't change them to negatives. All right, so let's plot these points. All right, well this one, it looks kind of like our linear function where it goes through all the squares diagonally, except it bounces off the x-axis there. And this one is pointy. It's not going to curve at the bottom. It's actually going to point at the bottom. There we go. That is the graph of an absolute value equation. All right, last one, square root here. So you might have grabbed your calculator and put this in, -9, the square root, and it didn't work. All right, it said error. Well, that's because if you try to take the square root of -9, you're saying what number times itself equals -9? Well, if I take 3 times 3, that equals a +9. If I take a -3 times a -3, well, that also equals a +9. So there is no number. There's no number that times itself will give us -9. There's no number times itself that'll give us -4. Basically, there's no number times itself that will give us a negative. So for now, we can't have negatives under square root. Now, that's not going to be forever. You're going to move on in math and find out there's such things as imaginary numbers, and that's allowed. But for what we're doing, because we want to graph them and we can't graph our imaginary numbers on this coordinate plane, there can't be any negatives under the square root. I'd write a little note to yourself on your piece of paper to make sure that you remember that. All right, y equals the square root of 0. What about 0? Does that apply to 0 too? Well, if I take 0 times 0, that does equal 0. So 0 is fine under the square root. So now y equals the square root of 1. I'm looking for a number that times itself equals 1. Well, 1 times 1 equals 1, so that'll work. And then y equals the square root of 4. What number times itself equals 4? Well, 1 times 1 equals 1. Let's try 2. 2 times 2, well, that equals 4. Okay, so you can see I picked different numbers here, right? I didn't just go 1, 2, 3 because I wanted to use numbers that I knew would work out well for you. So the square root of 4 is 2. And then lastly, y equals the square root of 9. We're looking for what number times itself equals 9. Well, 3 times 3 equals 9. All right, let's plot this. Well, we just said we can't have any negatives under the square root. That means that all these x's over here that are all negative, there's nothing on the graph here. So our graph is actually going to start here at 0, 0, then 1, 1, then 2, whoops, sorry, not 2, 1, 1, and then 4, 2. That's where I'm going. All right, so get those points in, and it kind of curves like this and goes up like that. There we go. That is our square root graph. All right, that's all of them. I hope you fixed your page and you have good notes for us to try to plot some of these on your own. Thanks for watching.